So when we talk about subtraction of integers, we're talking the same. We need to use the same model. We still need an end part. We still need an start, an action. But subtraction, the way we often describe subtraction is that it is a difference or a change. So a difference or a change really means that this is the action part. So when we talk about subtraction, the answer to it is the difference or change or the action or displacement. And this word displacement is something that you're going to need to learn at some point. Okay, we don't really use it a lot in grade 8, but as you get into older grades, we're going to use this word displacement because it's a very important term that we're going to use, and we're going to use it for all sorts of things in science and math. And okay, so we're going to need to understand what this idea of displacement is. Well, displacement is the change between 2 points. Okay, so the start and end are positions. Okay, and when we subtract, we always get the action or the displacement between those 2 points. So when we take a look here, it says, what's the change in height when a diver 5 meters above the pool dives into a pool at depth 2 meters? Well, if I draw my number line here, so here's +5, here's the water at 0, and here's -2. Right, so here's my water line there. Okay, so this is my start. We're starting here, we're ending here, and the answer that we're looking for is the displacement in between, or the change. Okay, so the way we want to find this, okay, we can probably figure this out, oh, we're going down 7. Okay, but we want to be able to set this up using this statement as well. To get the -7 or going down 7, we want to start with the end position. Okay, so that it looks like this. Again, I'm going to write it out. End minus start equals the action or displacement. Do that red here. Okay, so this is important to start getting used to. Okay, we're not going to use this model all the time, but we want to start getting used to this because it's very important once we start doing any kind of coordinate geometry, anything to do with graphs. It's really important to understand these concepts of number line, integers, this idea of end and start and displacement. So let's start with our end position here. We're going to end at -2 meters, and then we're going to subtract because we're looking for the change. Okay, subtract means change, or change means subtract. So we're going to subtract the starting position of +5. Okay, so if I do 2 minus +5, I'm going to end up with the action, which is going down 7. Okay, you've seen this integer operation before, but now we're just doing the same thing in a different context. 2 minus +5 means -7. Okay, which means that we've gone down 7. That answer represents the action of going down 7 from the start to end. So this is how we can model subtraction. We can model subtraction as the subtraction answer is the displacement or action, what happened in between 2 positions, 2 places on the number line. So when we look at this example here, it's always end minus start. So this 2 must represent the end position. And it's hard to remember. If you forget this, that's fine, because we'll be able to go over this again at some other point. But we want to start understanding that these pieces are involved here. So we have an end position of 2. Okay, so it's end minus start. So the starting position is going to be -5. So if I start at -5, if I start here, and I end at +2 here, this is my end, the action, or the displacement from here to here, okay, my displacement is going to be in this direction to the right. Okay, and how far did I go? Well, I can count it. It's 7. I went plus 7. Okay, we can see that when we do this subtraction statement, 2 minus negative 5, really that means 2 plus 5, which gives me the displacement or change of plus 7. Okay, so there it is. So the answer to the subtraction is the difference from end to start. Okay, so we can rewrite this as an equivalent addition statement. Okay, we can just do like we did before. Start plus action equals the end. We can say negative 5 plus, okay, we're going to add 7 or go to the right 7. There's my action. And it's going to be equal to the end position of positive 2. So these are equivalent addition statements. Okay, now we could also write this. We can interpret this slightly different way. And we can take the same statement and rewrite it and change these things. And just say this is 2 plus 5 equals 7. Now in this case, what we're saying is 2 and the displacement now is plus 5. We end up at a position of 7, positive 7. So this is another way we can interpret that same thing. Okay. However, if we want to keep the same pieces, start, end, and action, we can write it in this way. Okay, so this is really kind of what we're getting at. This one in the black is something you've probably seen before, so it's nothing new. So we want to look at a new way of looking at things. Okay, and this is an alternative way of looking at things, and you can always go back to your more comfortable way, but this is something I want you to start thinking about. We're going to use this when we start especially when we start talking about coordinate geometry.